So when we talk about the how to draw the Lewis structures, and you're taking notes, guys, come on. Let's start. The first thing you need to do is to find your element on the periodic table. So in order for us to know, we need to draw the Lewis structure, but of what element are we going to draw? So you need to find the element on the periodic table. And then you're going to determine the number of valence electrons. Something new. You have not heard about valence electrons. We have only talked about the total numbers of electrons an element had, right? Yes, no, maybe? Yeah. So today we're going to learn what are the valence electrons, and this will tell you how many valence electrons you're going to draw. So if I'm going too fast, let me know. Let me show you this. I don't want you to write down anything from this. I just want you to see it. Okay, we're talking about groups, and the groups will tell you how many valence electrons you're going to draw. And mainly the representative groups. What are the representative elements? What group? 18. Nope. What are my representative elements from group what to what? You didn't write that down? 1A to 8A. So what is 1A to 8A in your periodic table? What is 1A? 1. What is 2A? 2. What is 3A? 13. Very good. What is 4A? 5A? 6A? 7A? 7A? 17. And 8A? 18. Okay. So the representative, those numbers, those group numbers will tell you how many electrons you're going to draw. For example, here we go.
What was the last point on the first slide?
You will only draw the valence electrons?
No, the one.
Do you want us to write all that down?
No. No, I just want you to understand right now. Okay, this will tell you how many valence electrons to draw. So here we go again. First of all, you need to find out what element you're talking about. And that will tell you, in the group will tell you how many valence electrons it has. So, here we go. Another name for groups? Columns or families. Okay, very good. So, in here, we know that group 1, see, has only 1 valence electrons. Group 2 will have only 2 valence electrons. Group 3A, 3 valence electrons, 4A, 4 valence electrons, and so on. The maximum amount of valence electrons you can have are 8. So I want you to write that down. The maximum amount of valence electrons you can have is 8. No more than 8. And this, write down this one down. These electrons, okay, the electrons in the outer shell are called valence electrons. And I'm going to explain to you what it means, the outer shell. Those are the valence electrons. When we work with Bohr diagram, you're going to see how they're both linked together. So the electrons in the outer shell, those are the valence electrons. It doesn't mean that the rest of electrons don't exist. They exist, but they're in a different shell. So what is the maximum amount of electrons you can have? Of valence electrons? 8. Yes? No more than 8. Can I continue? Okay. So if I want to, and this, first of all, I want you to, this is how to draw the valence electrons. To draw the valence electrons, first you have to write the symbol. Write it down. So to write the Lewis structure, first write the symbol of the element. C. What is C, guys?
Carbon.
Carbon. Okay. Then we need to know in what group is carbon. In what group is carbon? See it in your periodic table. You all should have your periodic table out.
Group 14.
Or also known as
4.
4A. So how many valence electrons will it have? 4. So those are the 4 electrons that we're going to, valence electrons that we're going to draw. We're always going to start in the right, and then we're going to go counterclockwise. We're always going to start in the right, and then we're going to go counterclockwise. Can I show you before you continue writing? If we need to draw them, we're always starting where did I say?
You're right.
On the right. See it over there? And then we're going to go counterclockwise. How many are we drawing? 4. See it over there? 1, 2, 3, 4. Again, I'm going back. 1, 2, 3, 4. That's how we draw the Lewis structure. What is the maximum amount of electrons that we can have? 8. Okay, so right, you can draw that one for carbon in your notebook. Jordan, if you can't see, you can move from over there, okay, because of the video. Are we good with that one? So, can someone tell me what are the steps to draw the Lewis structure?
Write the symbol.
Write the symbol,
Find out what group it's in.
find in what group it's in, very good, and then?
Draw dots going counterclockwise.
Very good. And where do you always start?
The right.
On the right, yes, on the right. So, let's check, do we have 4 valence electrons? Yes, is it in group 4A? Yes, so we're right. Okay, now let's try another one. I want you to try for hydrogen. Come on, everyone, try for hydrogen. And I'm coming around to see what you're doing, and then I'm going to show you the answer for
Oh, okay.
hydrogen. It will be 1. This has only 1. This one has 2. No, it's the group. That will tell you how many valence electrons they have. So this is 1, this is 2, this is 3, 4, 5, 6, 7, 8. Someone doesn't understand how to do it? Raise your hand. Okay, hydrogen. What's the symbol for hydrogen, guys? H. Okay, yes. And how many dots are we drawing? 1. So is this your answer? Yes, you did it right. Okay, let's try phosphorus. Let's do B. Phosphorus. And by the way, that is a tricky one. Let's do it together. Let me explain this one. Whenever we're working with phosphorus, okay, we have already, and I want you to see this one for phosphorus. Phosphorus has how many valence electrons? 5. So we will always start on our right? Okay, so see it over there. 1, 2, 3, 4, and then you'll put the other one down or up, it doesn't matter. But as long as they're in this position, they're not going to be flying. What do I mean they're not going to be flying? You cannot put like this, phosphorus. 1, 2, 3, 4, and 5. That will be wrong. Okay, are we clear? This will be wrong. The electrons have to be one up and the other one down. Yes? Okay, let's try for calcium. Let's try for calcium. Remember, we're just drawing valence electrons. That doesn't mean that the rest of the electrons have disappeared. They're there. we're talking about the electrons that are in the outer shell, in the outside. These electrons will determine if they will lose or gain electrons. Do you have calcium, everyone? Yes? Okay, let's see. Calcium, 2, right? 1, 2. Yes? Okay, now we're going with argon. How many valence electrons does all group 18 or 8A have except for helium? Because helium doesn't have that many. 8. And I say except for helium because helium has how many electrons? 2. So obviously, helium is happy with 2. All elements, guys, want to have an octet. That means that they want to have 8 electrons because that means that they will be stable. So all elements will try to lose or gain electrons or even share electrons in order to have that perfect 8. So, argon, did you all draw it already? Nope, we're drawing. Let's draw argon.
For like the top ones, do you go here or here?
To the side. Very good. You're flying.
Oh.
Remember, we're not flying.
I would've
That means we
said that.
cannot put electrons like have another electron in here. Or up here, okay? They have to be to the side. Okay, are we good? Can we check argon now? How many valence electrons? 8. So let's start. 1, 2, 3, 4, 5, 6, 7, 8. Perfect octet. So that's why the noble gases, they tend not to join with anyone because they're complete, they're full. Any questions about the Lewis? Right now, I want you to work in the Lewis in your cards. Remember, you have your cards and I left you a space. Where goes my Lewis? In this side. In this one is where the Lewis will go. Okay, the circles are for board diagrams that I'm going to teach you later on. Okay, in here.